Hello class, welcome back. Today we're going to go ahead and continue sections 14 through 18. Right, I'm going to go ahead and solve a few examples here and there, right, that we may see in the homework, right, to clarify some questions I've been receiving, right. All right, so let's start with section 14, right, homework 14. All right, implicit differentiation, right, implicit differentiation. Right, they want us to find y prime, right, but we determined that this is equivalent to dy over dx, all right, dy over dx. And you're going to see me using y prime more often than dy over dx, but just know that they can be used interchangeably, right? So here you're going to be giving a function, right? You're going to be getting a function, and we're going to go ahead and derive, right? We're going to be deriving, right? Just if you notice, this is the majority of Cal 1, right? Of this calculus course, it's just taking derivatives, right? The only thing here is that we're going to see that some of our x variables are going to be multiplied by a y. Whenever that happens, I'm going to need to apply product rule. And the only addition to that would be whenever I take the derivative of y, I'm going to take its derivative and always multiply by a dy dx, or in other words, add a y prime right next to it, all right? Meaning, for example, right, if I had something like x plus 2y equals 3, right? I'm going to derive this from left to right. The derivative of x is 1, all right? Plus the derivative of 2y, right? That is just 2. But since I'm taking the derivative of y, I'm going to then multiply this by y prime equals 3, right? The derivative of 3, the derivative of a coefficient, right? Of a constant, it's 0. All right. So that's pretty much what I'm doing here, right? Pretty much what I'm doing here. So working from left to right, let me go ahead and take this derivative. All right, I see here that I have negative 44x to the third plus, they have an x and y multiplying, right? So that means whenever I have two terms that are multiplying, I'm going to apply product rule, right? Product rule, right? So f prime g prime, right? I'll let f be 9x and I'll let g be y, all right? F prime, that is just going to be 9, all right? Y, the derivative of y is just 1, and since I took the derivative of y, I'm going to multiply this with y prime, meaning my derivative is just y prime, all right? Right, so applying product rule, right? Applying product rule is g times the derivative of f plus f times the derivative of g. So that's what I get. Right, I'm moving across. This is plus 6y times y prime is equal to the derivative of 9.4, which is 0. All right, so I'm going to go ahead and polish some things up here, right? So this is minus 44x cubed plus 9y plus 9xy prime plus 6y y prime, all right? What I need to then do now is isolate y primes, right? That's going to be the variable I'm going to want to be solving for, and everything else is going to go to the other side, right? So I'm going to keep this here. And I'm going to move 44x cubed to the other side. And I'm also going to move 9y to the other side. So then I'm left with 9xy prime plus 6y y prime is equal to 44x cubed minus 9y. What can I do now, right? I'm trying to solve for y prime, right? I'm trying to solve for y prime. I see it's in both terms. So what you do here is you factor, right? You can factor it. I'm left with 9x plus 6y is equal to 44x cubed minus 9y. And last but not least, right, you're going to go ahead and divide both sides by 9x plus 6y, right? Go ahead and multiply by that entire piece. meaning y prime or dy dx equal to 44x cubed minus 9y all over 9x plus 6y, right? So that right there would be my final answer. All right, that right there would be my final answer, all right? Right, I have another example, right? I need to go ahead and find y prime, right? Y prime, I see that everything in the right doesn't have a y prime, so this is going to be a regular derivative, right? So the derivative of y is 1 times y prime, and everything to the right, what would we do, right? How would you solve this? How would you approach this? What would you do? Very nice, right? For those who said quotient rule, exactly what you would do, right? You would go ahead and approach this using quotient rule. All right, and then we have another one, right? Let's see here. You need to find the slope of the tangent line to the curve, right? You're given an equation and you're given a set of points, right? Whenever that happens, your answer needs to be a numeric answer, right? Your answer needs to be a numeric answer. One thing I wanted to add in addition is your dy dx is just your derivative, which is just your slope at any given point, right? And your slope is m, right? From college algebra, right? Digging some stuff from college algebra. So again, right, I would go ahead and derive this, right? And this is very similar to that first one, right? What I'm going to go ahead and do is derive this completely, right? 2x the bottom, the derivative of the top, minus the top, no, plus the top, bottom. Right, very nice. Minus 9y squared times y prime is equal to 0. Right, we go ahead and polish this up. Very nice, right? We said we get everything with a y prime to one side, right? So this here gives me negative 3xy prime minus 9y squared y prime is equal to 3y minus 2x. You factor a y prime and you divide by what was not factored, right? Or the other part of the factor, right? Or the resultant of the factor, right? So you get y prime is equal to 3y minus 2x over negative 3x minus 9y squared, right? And that point that they give you, right? They give you 1 comma negative 1, right? In other words, this is x equals 1 and y equals negative 1, right? So what you would go ahead and do now is to find your slope at that specific point. The same thing is you would go ahead and plug it in. You would plug in those values into here, and the numeric answer you get would be your final answer, right? Right, moving forward to section 15, right? Homework 15. Homework 15 deals a lot with word problems, right? I believe 18 as well, right? I believe 18 does it as well. One thing to remember that I need you all to remember, especially if you're moving on to physics class, right? This class here is important, or just right, if you're not taking any physics, still, right? You have what's known as position, right? Position. If you have position, and if you were to take the derivative of this, you get velocity. If you derive velocity, it gives you acceleration. So remember that. And also, in case this comes in handy, if you take the absolute value of velocity, you speed. For these word problems, right, especially for the business majors, you're going to be giving a C function. If you're asked to find the marginal cost, that means you're going to get C and take the derivative of that C function. Right. For example, here, all right, right? For example, here, right? You're given this word problem, you're giving a function C and you're given a function R, right? If you're asked to find the marginal cost function, right? The marginal cost function, you're going to take the derivative of C. If you're asked to find the marginal revenue function, this would be the derivative of R, right? And if you're asked to find marginal profit, all right, marginal profit is equivalent, where is it at? To revenue minus cost. Revenue minus cost. Very, very nice. Right, so that's how you find that value. Right? Okay. All right. You're gonna. Right. We've been deriving a lot. Right. We've been deriving a lot. One thing you're going to go ahead and find is finding average velocities. Right. Average velocities. If you're given instantaneous velocity, you're going to take the derivative of your function and plug in the value that they ask. Right? That's what instantaneous velocity means. You plug in the derivative that they give you, you take the derivative and you plug in the value, right? To find average velocity, you're going to use the formula f of b minus f of a all over b minus a, all right, which we know is our slope function, all right? Right, so for problem A, they want you to find that between these 2 points, right? Whenever they give you points, A is going to be the first point, B is going to be the second point. All right. F of A, all right, this just means you're going to plug in A into the function that was given to you, right? That function up there. Right, so F of A just means f of 0.7, which means I'm going to plug in that value into that function. All right. I'm going to go ahead and plug that in. This here gives me 34.93. Right, so you're going to go ahead and plug in the same thing for f of b, right? You're going to plug in b into your f function. All right. Go ahead and plug that in. Right, and I get, and hey, right, you now have everything you need, right, to use this formula, right, to use that formula. So, right, we're going to go ahead and 62.73 minus 34.93 all over b, which was 1.7 minus 0.7, right? And you'd find out 62.73 minus 34.93. This gives me 27.8 divided by 1. Is off. 27.8 divided by 1, which is just 27.8. Right? And that right there would be your final answer. Right? And you would go ahead and do that with B as well, right? But you would have to do this all over again because you have a new A and B value. All right. Okay, so this one's going to differ a little bit from the previous ones, right? This here is going to differ a little bit from the previous ones. All right, so here you need to take the derivative of both values of x and y, but with respects to time now, right? Respects to time, right? Not with respects to x, with respects to time, meaning that if you take the derivative of x now, all right? Right, if you take the derivative of x now, you are now going to write dx over dt. And if you take the derivative of y, you're going to write dy over dt. All right? So here, right, this pre-example, the derivative of 2x is 2, but I'm going to multiply it with dx over dt. Then I'm going to take the derivative of y, which is negative 6y times dy over dt. 0. All right. I'm going to go ahead and apply that here. All right. The function given is xy equals 2. Two values that are multiplying. I need to go ahead and apply product rule. All right. And I'll let you go ahead and pause this video, right? Find f, which is x, g, which is y, right? And take the derivatives, right? So I get the bottom, right? And if you hear me, he's talking and it sounds like nonsense, I have, right? Hopefully we all create our own way to learn how to, right, memorize this, right? And that's all I'm doing, right? So I have the bottom times the derivative of the top times the derivative of the bottom. Derivative of 2 is 0. Right, so polishing this up, right, I get y times dx over dt plus x times dy over dt. Right, and they give me a few values, right? They give me a few values. They give me what dy over dt is, right? That is 1, and they want me to find dx over dt. All right, dx over dt, right? So let's go ahead and isolate dx over dt, right? That's what I'm trying to solve. I'm going to subtract this from both sides, right? So this here gives me y times dx over dt is equal to negative x dy over dt, right? And I need to get dx over dt by itself, so I'm going to go ahead and divide both sides by y, all right? Meaning, right, dx over dt is equal to negative x over y times dy over dt. All right, very nice. Very nice. All right, so at this point I have everything that I need to go ahead and plot this in. All right, meaning dx over dt, right, at these specific values, x is equal to negative 2, y, that is not given, dy over dt is 1. All right, meaning dx over dt is equal to negative 2 over y. All right, and that right there would be my final answer. And the reason this is helpful, right? We for real world life scenarios, right? Real world life scenarios, right? So a spherical snowball, right? It's snowing in Houston. I believe it was snowing this last year, right? It was last year. I think it was this past year, right? You're right. You got a snowball, right? A really nice snowball, and you realize, right, that its radius is decreasing at a rate 0.2 centimeters per minute. So they're already giving you the rate of change of radius. And that's very interesting. I'm going to use that. That is not radius. That is the rate of change of radius, right, over time. At what rate is the volume of the snowball decreasing, right? So here they want to know the rate of change for volume, right? That's what I'm looking for. I'm not looking for volume. I'm looking for the rate of change of volume over time, right? They want me to find that whenever the radius is 12 centimeters. Now that is my radius, right? 12 centimeters, right? The hint I give is volume is equal to 4/3 pi r cubed. All right. What I need to go ahead and do now is derive with respects to time, right? Derive with respects to time, all right? And just like the XY example we did before, whenever you take the derivative of a variable, you're going to write d, that variable, over dt, right? So the derivative of v, right, is just 1 times dv over dt is equal to 4/3 pi, the derivative of r cubed, this is 3r squared, times dr over dt. Polishing this up, right, I get dv over dt, the derivative of v over time, is equal to 4 pi r squared, the derivative of r, the change of r over time. All right, and they give me that information, right? They're letting me know that the radius is changing 0.2 centimeters per minute. They're letting me know I need to go ahead and find dv over dt. Right? That's what I need to go ahead and solve for. And I know that the radius is 12 centimeters. Right? And hey, that's everything on the right-hand side. Let me go ahead and plug all this in. All right. When I go ahead and plug all that in, 4 pi times 144 times 0.2. This gives me approximately 361 point, we said 2 decimal places, right? I believe 361.91. All right, very, very nice. Very, very nice. Very, very nice, right? And if you wanted to know units, right, this here would be centimeters cubed per minute, right? Since we stated earlier, volume is dealing with cubed units. All right, very, very, very nice. Right. Now we're going to go ahead and be moving on to section 16, critical points, right? We're going to go ahead and be dealing with critical points, right? Critical points are wherever you have a max and a min in your equation, right? In your graph, right? You may be, right? They're called critical points. They're called extrema, all right? Max or min, right? Max, min. It's all the same word, right? The word is used interchangeably, right? So right in here, this would be a critical point. For this other one, this would be a critical point. This would be a crit. And that right there would be a crit. All right. Right, so hey, right, I give you a function and I need us to apply the first derivative test. All right, I need us to go ahead and apply the first derivative test. All right. So what I need to go ahead and do is take the first derivative. I need to go ahead and take the first derivative. This here gives me negative 12x squared plus, I'll go ahead and do that, 32.58. This gives me 65.16x plus 83.46. All right. What you need to go ahead and do now is equal this to 0, right? You get your derivative, you equal it to 0. To 0, and you solve, right? You need to go ahead and solve now, right? And right, this is a quadratic function, right? This is a quadratic function. So what would be expected from you is to use the quadratic formula, right? You must use the quadratic formula, right? You must use the quadratic formula, right? Whenever you do that, all right, let's see if I can do this to work. All right, you're going to go ahead and get two values, all right? You're going to go ahead and get x is equal to 1.1 and x is equal to 6.5. All right, x is equal to 1.1, negative 1.1, I'm sorry, negative 1.1, and x is equal to 6.5, right? So right now, what I'm going to go ahead and do now is create a horizontal line, right? I'm going to go ahead and plot this point here. This is a critical point. And I'm going to go ahead and plot here this one as well, 6.5. Right? And I don't know if these are maxima or minima, right? I don't know if these are maxima or minima, right? So what I need to go ahead and do now, second. Right, what I need to go ahead and do now. What's going on? I'm sorry, guys. Give me 1 second here. I think froze. And we're back. Thank you. Right. What we need to go ahead and do now with this first derivative test is apply a test, right? It's apply a test. I want to know, what is the graph doing to the left of negative 1.1? All right. I need to know what it's doing at negative 1.1. All right. And it should actually be negative 1.07 because it's 2 decimal places. My apologies. Right. But if you were running to 2 decimal places, right, 1 decimal place, it'll be negative 1.01. Negative 1.1. Right, so what I need to go ahead and do to find out if the graph is increasing here or decreasing is you're going to choose a point to the left of 1.07 and plug it in into the first derivative, right? You're going to go ahead and plug it into the first derivative, right? So I'm going to go ahead and apply x is equal to negative 2, right? I'm going to go ahead and apply that to my first derivative, right? You're going to go ahead and plug that into there. Right? And yes, you need to show your work, right? You're going to plug that into there. And you're going to find out that this gives you you're not really worried about the number itself. You're worried about the sign, right? You're worried about the sign. This here gives me negative 95, approximately negative 95. That is a negative value. So I know this is decreasing at this point, right? You're then going to choose a point, a number between these two crits, right? Between these two critical points, and apply it to the first derivative, right? The nice one would be 0. You apply 0 into the first derivative. You find out that this gives you 83.46. That is positive, right? You're not worried about the number. You're worried about the sign, meaning between here and here, this is increasing, right? And if you plug in to this side of the critical point, all right, this here, let's just say 7, right? You go ahead and apply 7 into the first derivative. And you find out that this gives you approximately negative 0.48.42. And again, you're not worried about the value, right? You're worried about the sign. So this is decreasing, right? Meaning, right, that this graph does approximately something like this, right? Where this point here is my max, and that right there is my min. All right, so this is a guesstimate of what it does, right? This is a guesstimate of what it does. If I wanted to know the interval in which this is increasing, right, you're going to go ahead and use your x values. All right, this is increasing. Well, I use the first derivative test that is increasing between negative 1.07 and 6.5. Right, and we know that this is decreasing. All right. Between negative infinity and negative 1.07, and between 6.5 to infinity. All right. So very, very, very nice. All right. That right there is applying the first derivative, right? The first derivative. Let's go ahead and do another first derivative. All right, first derivative test. All right, and now they want to know, hey, if you have a minima, if you have a maxima, and if so, what is that value, right? What is that value? All right, so again, right, first derivative test. I'm going to go ahead and take my derivative. Right. I'm going to go ahead and equal this to 0. And hey, I know that this begins with a 6. I can go ahead and try to divide everything by a 6, which it does. And I can go ahead and solve for x now, right? I need to go ahead and solve for x. This is a pretty straightforward one. I can use a C method here. All right. This gives me what? Minus 6 minus 5. Right? Minus 6 minus 5. Solving for x, right? Applying the zero product property. All right, I get x is equal to 6 and x is equal to 5. All right, so those right there are going to be my critical points, right? My critical points. Right. This is 5. This is 6. All right. This is a crit. It's a critical point. I'm going to go ahead and apply 4 into my first derivative. right, to see what I get. Right, and you can go ahead and apply to this one. You can go ahead and apply to that one right there. Right, you go ahead and apply 4 into there. So 4 squared minus 44 plus 30. This gives me 2. Right, this gave me positive 2. I'm not worried about the number. I'm worried about the sign, and that's increasing. Right. Right now, I'm going to go ahead and choose a value between those two. Let's go ahead and do 5.5. So this is 5.5 squared minus 11 times 5.5 plus 30. This gives me negative 0.25, right? Negative 0.25, that is decreasing, right? And whenever we go ahead and apply 7 into the first derivative, right? I get 49 minus 77 plus 30, plus 30. I get 2, right? I get 2. So in other words, this is positive 2, this is increasing or decreasing, right? Meaning this one here is my max, and this one here is my min, right? If you want to know the value in which 5 is a max, right? If you want to know the value in which it is a max, you plug 5 into the original equation, right? Because every x has a y that corresponds to it, right? So that's what I'm going to go ahead and do. I'm going to go ahead and plug 5 into there, all right? And this here is going to give me 2, 5 to the third, minus 33, 5 squared, plus 180 times 5, plus 2. Right, and I'm going to see what that gives me. 2 times 125 minus 33 times 25 plus 180 times 5 plus 2. Right, and I got 327. All right, so max of x is equal to 5 at 327, right? Gives me the value of 327, right? Oh, it is right here, right? It gives me right here, max, right? We can go ahead and see the answers there, right? And I would go ahead and let you apply the same thing, right? Apply the same thing with the minimum, and it's the exact same thing, right? It is the exact same thing. Exact same thing, right? So now we're going to go ahead and be locating, we're going to be applying concavities, right? Concavities, right? So there are things known as inflection points, right? Inflection points. An inflection point is a point between a max and a min, where it, right? This right there is known as an inflection point, right? It's between a max and a min. And the great thing about that is that there's that at that breakaway point, for example, for this problem, to the left of this graph is what's known as concave up, right? It is concave up, right? And generally what I do, you cannot see my fingers, right? Let's see if I can go ahead and, yeah, I cannot use my camera, right? I make a U with my hand, right? I'm gonna go ahead and let's see if I can go ahead and draw this, right? I make a, that's my hand. Excuse me, right? That is a U. That is a U with my hand. That is right. I'm cupping it, right? It is U. This is concave up, right? Concave up, right? My fingers are pointing up, right? And you may say, hey, what is this one? Well, that one is going down, right? That is concave down, right? So in other words, if you had your fingers, I'm not an artist, right? That's a little bit better, right? If you go like that, right? If you point your handward downward, this is pointing down, right? This is concave down, right? Concave down. All right. So this is what we're going to be locating in this section, right? Concavity, right? Concavity. How about here? There is no inflection point, right? Because an inflection point gives you, right? It breaks away an inflection point breaks two concavities up, but not for this one, right? But you can ask yourself, right, is this concave up or is this concave down? All right, you're going to go ahead and go back to this graph, right? And we're like, it's that one, right? That is known as concave up, right? That this quadratic function, right, is concave up. We're going to go ahead and apply what's known as the second derivative test, right? We're going to go ahead and apply now what's known as the second derivative test, dealing with concavity, all right? Dealing with concavity. All right, so you're going to go ahead and take the first derivative, of course. Right? Here's going to give me 6x squared plus, oh, what am I doing? 12x plus 9, right? And then we're going to go ahead and take the second derivative, 12, all right, which is 12. All right, so I see here, all right, that let's go ahead and take the first derivative and equal this to 0, all right? Oh, and real quick, since the second derivative, there is no x value, right? There is no x value that I can solve for the second derivative. That means it doesn't have an inflection point. There is no inflection point for this, right? And we know this is a parabolic function, right? A quadratic function, and very similar to what we saw earlier, right? Parabolic functions do not have inflection points, right? But it does have a critical point, right? It does have a critical point. So I'm going to go ahead and apply the first derivative test. Right? Means get the first derivative equal it to 0. All right, and I'm going to go ahead and solve for x. All right. And you get x is equal to -3/4, right? -3/4. All right. So you can go ahead and apply the first derivative test. You can go ahead and apply what's known as the first derivative test, right? And you're going to see what we can do to the first derivative test and how we can use the second derivative test to tell us about concavity, right? So we said we're going to go ahead and apply, right, using the first derivative test. I put -3/4. We'll put to 0 and we'll use 1. This is my critical point. Let's plug in 1 into the first derivative and let's see what I get. All right, let's go ahead and plug in 1 into my first derivative and let's see what I get. I'm sorry, -1. -1, right? You apply -1 into the first derivative and you get a negative answer. All right, you get a negative answer. So we get this, right? -12 plus 9 gives me -3. You apply 0 into the first derivative and you get 9, right? So this goes up, right? Meaning this is concave up, right? It's increasing from -3/4 to infinity, and it is decreasing from -infinity to -3/4, right? And this is concave up, right? You would say this is concave up from -infinity to infinity. Is it concave down? No, it's not concave down, right? It's not concave down, right? So very, very nice. Also, the second derivative tells you the concavity of this function, right? If your second derivative, what happened again? Give me 1 second. Thank you. Awesome. Right. So, and like I was saying, the second derivative, right? The second derivative test tells you about concavity, right? So you took the second derivative and it gave you no x values. That's fine, right? So it's going to tell me everything about this graph. It's positive if your second derivative is greater than 0. If it's positive, it means this is going to be concave up. If your second derivative is negative, less than 0, it's concave down. Hey, you took your first derivative, your second derivative, it gave you a positive value at the end. This means that this entire graph is concave up. All right. Let's go ahead and find more, right? Right, this is still pretty similar to what we were doing earlier, right? Finding critical numbers and determining if they're absolute, the extrema, right? This is very, very similar to what we were doing. Coming back, there we go. Coming back to some word problems, right? Going to some word problems. Let's go ahead and see here. Is this the one I wanted to give? Find the production of, yes, there we go. This value here. Right, so what we need to go ahead and do here, right? One thing that's not given is my revenue function, right? Revenue function. Remember, our revenue function is x times p, meaning my revenue function here is x times 2130 or 2130x. Right, that is my revenue function. All right. To find profit, what do we think that is? Yes, that is revenue minus cost. All right, so my profit here would be 2130x minus cost function. Right, you distribute that negative and you combine like terms, right? I get 2130x minus 4600 minus 710x minus 1.3x squared. Right, let's go ahead and rearrange these and I get negative 1.3x squared plus 1420x minus 4600, right? That is my profit function, right? Hey, I want to know when this is going to be maximized, all right? What's going to cause this? Which x value is going to cause me to have maximum profit, right? Well, right, this is what we've been doing with this entire section, right? With this homework week, right? Is you take the first derivative and you equal it to 0, right? So this here would be negative 2.6x plus 1420, right? I'm going to go ahead and equal this to 0. Meaning, right, I'm trying to solve for x, so I'm going to subtract 1420 to both sides. I get negative 2.6x is equal to negative 1420. Divide both sides by negative 2.6. Right? So x is equal to 1420 divided by 2.6. Let's do 2 decimal places, right? 546.15. That right there would cause me to have maximum profit, right? Maximum profit, right? How about here? The concentration of drug T hours after being injected, right, is given by this given function. Find the time when the concentration is a maximum, all right? What would you do here? Here you would derive, right? You would go ahead and derive, right? And hey, you have a rational function. Right, you have a rational function. So yeah, I would say we need to go ahead and apply quotient rule, right? Quotient rule, right? You can go ahead and do it your way. But you know, for the sake of the video and time, let's go ahead and solve it, right? You can go ahead and pause it at any time. It is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. As a friendly reminder, right? If you're doing these, you must simplify the numerator, right? And I mentioned this in a previous video, right? You must simplify, right? So my prime function, my C prime function is, right, 0.1 t squared plus 4.1 minus 0.2 t squared all over the bottom squared. I'm sorry. And we said we equal this to 0, right? You get your first derivative equal to 0. And I can still continue simplifying, right? I can still continue simplifying, right? This here would be negative 0.1 t squared plus 41 all over t squared plus 41 squared equals 0, right? All right, let's see here at the bottom. That's the derivative of the top. Minus the top times the derivative of the bottom all over the bottom squared. Very nice. So I got 0.1 t squared. Just double checking my work. Very, very nice. Excellent job, right? Excellent jobs, right? So what I'm going to go ahead and do now is I'm going to go ahead and equal this to 0. And I'm going to multiply both sides because I want trying to get rid of the denominator. I'm going to multiply both sides by t squared plus 41 squared times t squared plus 41 squared, right? These two cancel out. not the top part, right? So that's, I'm just going to get 0.1 t squared plus 41 is equal to 0. All right. I'm going to solve for t squared. I'm going to go ahead and subtract 41 to both sides. I'm going to go ahead and divide by negative 0.1. Right, and that gives me what? 41 divided by 0.1, 410. There we go. So I get t. Give me 1 second. Oh, 4.1. I'm sorry. This should be 4.1. Right. 4.1 divided by 0.1. All right. All right, and this here gave me t squared is equal to 41. All right, and hey, last but not least, you go ahead and take the square roots to both sides. All right, t is approximately the square root of 41. This is 6.3124237. All right, 2 decimal places, right? So t is approximately 6.40 hours. Right, that's how you would go about that. All right, and that is all I have for today. Right, that is all I have for today. Thank you very much all for your time and hope you enjoy the rest of your day. If you have any questions, please do not hesitate to contact me via email. Right? Thank you very much.